See any difficulty in understanding the diagram?
No, sir.
Have you finished taking this diagram?
Yes, sir.
What about others? Please give others also response.
Yes, sir, completed.
Okay. So what you are understanding with this diagram is, like here we are having the three stages, as we have seen that, like the equation what we have taken is n equals to 2 to the power v, right? So if it is a 8 point, what we are writing, v equals to log to the base 2, that is n by 2 log to the base, or v we are calculating that v equals to log to the base 2 n value is 8 here. So what we can write, so we can write it as like this. यहाँ पे ऐसा लिख सकते हैं इसको. So it is as already I discussed, so that v is equals to, like we are considering the equation like n equals to 2 to the power v. So where v equals to, we are writing it as log to the base 2 n. What is the value n here? N is log to the base 2, n value is 2, that is 8, or this I can write it as simply log to the base 2, 8 can be written as 2 to the power 3, or this can be written as simply 3 into log to the base 2, 2. The value of this is how much?
3.
Log to the base 2 is 1. So it is 3 into 1, the value is 3. The number of stages required are 3 for performing the calculation. Okay. So that's how we can understand for 8 point we require the 3 stages. तो यहाँ पे इसको क्या करो अभी, like you just write this is the first stage calculation, right? So here if you want to just write this is stage 1. Let's write it as stage 1, right? The next second stage, this is stage 2, we can write again. So here again I can write it as a stage 2. So this is stage 2 and this is stage through computation. Okay, like 3 stage computation we need to do. तो पहला हम क्या करेंगे यहाँ पे? So first what we are doing, we are dividing or we are converting the given sequence into the odd number sequence and even number sequence. What you are observing in the input side, can anyone tell me? Here the inputs are applied in a bit reversal order. Getting my point? So this is what we are calling it as the bit reversal order. इसका मतलब मैं बताता हूँ आपको why it is called as a bit reversal order and why to apply a bit reversal order sequence. So here how do you like this bit reversal order sequence we are applying now? तो यहाँ पे, so this is the stage 1 output we are calculating first, right? तो यहाँ पे आपके value आ जाएंगे. So what values you are going to get? So here we will write like first value as x1 of 0 for the first stage. Okay. So likewise we will write the values up to x1 of 7. ये अपने first stage के output हो गए. Getting my point? Yes?
Yes, sir.
तो पहले हम first stage का output calculate कर रहे हैं. Once if you calculate this output, so then this output will become as an input to this stage. ठीक है, मतलब second output of a first stage will be input for the second stage. तो ये output हम बाद में calculate कर रहे हैं. We are calculating this like second output we are calculating again. So then, so this we are writing it as second stage, like x2 of 0 is we are writing here x2 of 0 and then up to x2 of 7. Right, x2 of 7 we are writing it is. So this is how we are calculating the second stage output, and finally this second stage output will become the input to the third stage, and we'll write the final values as x of 0, x of 1, x of 2, x of 3 likewise. So this is what the procedure of solving the example again. Understood?
Yes, sir.
Any difficulty here?
No, sir.
Now let's move to the further part. Just note down this point. This is very important again. For n equals to 2 to the power v, you write it is. For n equals to 2 to the power v, as we are going with v, we will go with v only. N equals to 2 to the power v. Below that you write. There are v stage synthesization. There are v stage synthesization. V stage synthesization. Each has n by 2 butterfly computations. Each has n by 2 butterfly computations. क्या मतलब है इसका? कोई बताएंगे मुझे? Yes, anybody? What you are understanding with this? Hello? Am I audible?
Yes.
So what you are understanding is there are V stage synthesization. Each has n by 2 butterfly computations. Matlab, for example, we have considered here this 8-point stage, like 8-point DFT we are calculating total stages कितने हैं यहाँ पे? 1, 2, 3 stages है. मतलब V equals to 3 होगा यहाँ पे. But each stage has n by 2 number of butterflies. n कितना है आपका? 8 है. So 8 by 2. What is the value?
4.
4. मतलब each stage में आपके 4 बटरफ्लाई यहाँ पे. So this, look at into this. This is 1, 2, 3, 4, right? 1, 2, 3, 4. Like 1, 2, 3, 4. मतलब each stage में आपका 4 butterflies are there. Understood?
Yes, sir.
Now, write that. So there are V stage synthesization. Each stage has n by 2 butterfly computations. Full stop. Each butterfly computation has one complex multiplication. Each butterfly computation has one complex multiplication and two complex addition. One complex multiplication and two complex addition. Before that, you just write like two complex addition. After that, you just write one more line. The total number of butterflies required. Total number of butterflies required. Just write the formula is equals to what we can write. I think I have given that formula to you. N by 2 into V. What is the formula we are having? The total number of butterfly operations is equals to n by 2 into V. So what you are going to write for V again? V के लिए क्या लिख रहे? Yes. So this is what we are writing for V. V is equals to, we have it is log to the base 2 n. So that means the number of butterflies required will be the value we are writing it as. So n by 2 into V. So this will be equals to n by 2 into V is how much? Log to the base 2n. Suppose n आपका 8 है. Let us assume that n equals to 8. So then what we will write? So it is 8 by 2 into log to the base 2 into 8, which will be equals to आंसर क्या आएगा?
12.
Yes, it is 12, like 4 into 3. So which will be equals to 12. Can you check that whether how many number of total butterflies are there in total computation?
12, sir.
12 are there na, each stage is having the 4 butterflies, तो वहां पे total 12 butterflies are there. Okay, so then please note down this. The number of butterflies operation is equals to n by 2 into v, and v we are writing it as log to the base 2n. So 8 by 2 log to the base 8 to 8, then the value is 12 for n equals to 8. Okay, now just write next line. The number of complex multiplication required. Next line you write. Total number of complex multiplications is. The total number of complex multiplication is equals to you can write n by 2 into v, you write again. This is same as the butterfly operations also. N by 2 into v is equals to n by 2 log to the base 2 n. Already we have seen this formula. N by 2 log to the base 2 n. Or
Yes, sir.
the next, just write the total number of complex addition. The total number of complex addition is क्या formula है? So already I have given you the formula for this.
N into V.
It is n into v, so that means we can write n log to the base 2 n. N into v, and we can write n log to the base 2 n. This is the formula. Can you remember these formulas? You may expect these
Yes.
as a MCQ question also again. The total number of complex multiplications required for FFT, DIT FFT, or the total number of complex addition required for DIT FFT is, with the formulas you need to calculate. Okay. The next title you just write the characteristics of DIT FFT algorithm. The next title you write the characteristics of DIT FFT algorithm. Characteristics of DIT FFT algorithm. There are mainly two characteristics are there. One is bit reversal order. You just write bit bit reversal order. Bit reversal order. And second one is memory requirement and in place computation. Second is memory requirement and in place computation. So let us see one by one. So first just write memory requirement and in place computation. You first take the memory requirement and in place computation. And you draw this diagram. Or
Yes, sir.
now, with this diagram, we can understand like how much memory is required and how we can use this in place computation. So यहाँ पे what you are understanding with this butterfly diagram, तो यहाँ पे this small a and small b are the inputs and capital A and capital B are the outputs. बराबर? Yes or no?
Yes, sir.
Now this
Yes, sir.
capital A, we are calculating with the value of A and B, and this capital B we are calculating by subtracting with the value of A minus B. So that means here one butterfly requires, what is the memory location or the how many number of memories? Like 4 memory, right? So it requires, so the 4 memory location, मतलब आपको ये वैल्यू स्टोर करना है, स्मॉल बी का वैल्यू स्टोर करना है, कैपिटल ए का वैल्यू स्टोर करना है और कैपिटल बी का वैल्यू स्टोर करना है. गेटिंग माय पॉइंट? सो यहाँ पे इन दिस बटरफ्लाई डायग्राम और इन दिस एफएफटी एल्गोरिथम, वंस इफ यू आर कैलकुलेटिंग दिस कैपिटल ए एंड बी, तो इसका जरूरत नहीं है स्मॉल ए और स्मॉल बी का. गेटिंग माय पॉइंट?
Yes, sir.
So that means once if you know the value of capital A and capital B, then there is no requirement of storing this small a and small b. So that means we can store the value small a in place of capital A, or we can store the value small b in place of capital B. So that means, so once the memory requirement we are reducing here with the help of this in place computation. Means what? As we are calculating the value of AB with the help of this capital A and B. So that means the value of A plus B is stored in the value A and A minus B is stored in the value of B. Once if you noted the value of capital A and capital B, so this will act as the input to the next stage. No need to go for this initial stage again. So that's what we are calling it as a in-place computation again. So with this, we can reduce the memory requirement with the help of this in-place computation. Okay? Getting my point?
Yes, sir.
Just note down that. From figure, we can observe that from figure, we can observe that from figure, we can observe that from values small a and small b, from values small k and small b, we can compute capital A and capital B. We can compute capital A and capital B. Capital A and capital B. Full stop. Once A and B are computed, once capital A and capital B are computed, once capital A and capital B are computed, there is no need to store, there is no need to store small a and small b. There is no need to store small a and small b. Thus, same memory location can be used to store. Thus, same memory location can be used to store, capital A minus capital B, capital A minus capital B, where small a minus small b, where small a minus small b were stored. WERE. Small a, small b, a minus b were stored. Full stop. Were stored. Full stop. Since since A comma B, that is capital A comma capital B, or small a comma small b, small a comma small b, are complex numbers, are complex numbers, complex numbers. They need two memory location. They need two memory location each. They need two memory location each. Full stop. Thus, for computation of, thus, for computation of one butterfly, for computation of one butterfly, 4 memory locations are required. Thus, for computation of one butterfly, 4 memory locations are required. That is 2 for small a or capital A, 2 for small a or capital A, and 2 for small b or capital B, and 2 for small b or capital B. Full stop. Next line you write. Memory location for one butterfly. Next line you write. Memory location for one butterfly. Memory location for one butterfly is equals to 2 into 2 is equals to 2 into 2, which equals to 4. Just make it as underline. 2 into 2 equals to 4. Make this complete line with the underline. Finished?
Yes, sir.
Yes, sir.
Next line you write. In such computations, next paragraph you start otherwise. In such computation, capital A is stored. In such computation, capital A is stored in place of small a, in place of small a, and capital B is stored, and capital B is stored in place of small b, in place of small b. This is called, in place of small b, this is called in place computations. This is called in place computations. This is called in place computations. Full stop. The advantage of in place computation, the advantage of in place computation is that, the advantage of in place computation is that it reduces, is that it reduces memory requirement. It reduces memory requirement. It reduces memory requirement. Hope you all have understood what is memory requirement and in place computation.
Yes, sir.
Okay, just write one more line. According to the signal flow graph diagram, according to the signal flow graph diagram, for n equals to 8, for capital N equals to 8, n equals to 8, we observe that, we observe that, we observe that there are n by 2 butterflies, there are n by 2 butterflies, full stop. Hence, one stage will be, hence, memory location for one stage will be. Can anyone tell me the answer for this? Just make underline to this line. Memory location for one stage will be equals to, what is the answer?
4.
How 4, madam? In stage 1, we have observed that n by 2 number of butterflies. Okay. But for one butterfly, we require the 4 memories. What will be the answer? For one complete stage, I am talking.
Twelve.
No. 12 is okay. Even it's not 12. एक स्टेज में आपका कितने बटरफ्लाइज है?
4.
4 butterflies are there. And one butterfly requires how many memory location?
4, sir.
4. One butterfly require 4 more memory location. And in one stage, we have 4 number of butterflies. So 4 into 4, it is 16. Barabar?
Yes, sir.
So that means you just write. Hence, the memory location for one stage will be equals to 4 into n by 2. We will write it in generalized way. 4 into n by 2 is equals to 2n. Just write capital N, it is 2n. Okay. Understood?
Yes, sir.
Next line you write. Next line. In signal flow graph, we observe that in signal flow graph, we observe that in signal flow graph, we observe that in every stage, there are n by 2 twiddle factor required. There are n by 2 twiddle factor or butterflies you can write. N by 2 twiddle factor required. N by 2 twiddle factor required. Full stop. Hence, the maximum storage requirement. Hence, the maximum storage requirement of n-point DFT, maximum storage requirement of n-point DFT, including twiddle factor will be, 2n, including twiddle factor will be 2n plus n by 2. 2n plus n by 2. Please make it as underline again. Including twiddle factor will be, it is simply we are writing it as 2n plus n by 2. It's like this. 2n plus n by 2. So this is the total number of memory location required to perform a complete DFT with the help of butterfly diagram, right? So this you need to remember again. So once I think this question has asked in examination, explain about memory requirement and in place computation for 4 marks. So you need to write all these answers. Okay. Then what is next? We have a bit reversal order. So now, hope you all have understood what is memory requirement and in place computation. Any confusion
Yes.
here? Any confusion?
No, sir.
No, sir.
Okay. let's move to the next part. Bit reversed order or bit reversal order we can write. Bit reversal order. So let me tell you in other way. So have you noted the title? Bit reversal order.
Yes, sir.
Now we will write it in this way. यहाँ पे हम क्या लिख रहे हैं अभी? So let me write here. The first I will write 8-bit number. So we will write 0, 1, 2, 3, 4, 5, 6, 7. ठीक है, अपना नॉर्मल नंबर है ये. Then if you want to write its equivalent binary number, तो क्या लिखेंगे हम यहाँ पे? Equivalent binary number 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, and all ones. Are you noting this? Hello? Are you noting this?
Yes, sir.
Yes, sir.
So first I have written a simple our normal number from 0 to 7. Then second is just write if you require equivalent binary number. This is simply equivalent binary number. Then here you write the bit reversal or bit reversed order. So इसको अगर reverse करेंगे आप तो 0, 0, 0 कुछ change नहीं आएगा. So what will be for this? What I will write?
100.
It is 1, 0, 0. The next
0,
0, 1, 0. Then 1, 1, 0. The next 0, 0, 1. Then 1, 0, 1. Then 0, 1, 1. And then 1, 1, 1. ठीक है? Understood this bit reversal?
Yes, sir.
Now you write its proportional equivalent number. तो इसका नंबर क्या आएगा अभी? 0. What about this?
4.
4. और ये 2. This is again 6. ये अपना पहला इनपुट है 0, 4, 2, 6. है क्या? डायग्राम में देखो एक बार.
Yes, sir.
बराबर. देन सेकेंड आधा पार्ट क्या लिख रहा है यहाँ पे? व्हाट इज दिस? दिस इज 1, 5, 3, 7. ये दूसरा पार्ट है आपका. Yes or no?
Yes, sir.
Yes, sir.
Right? So this is what we are calling it as even number. ये आपका even numbered sequence है. This is our even numbered sequence. This is the odd numbered sequence. And here you need to remember one thing for DIT FFT algorithm के लिए, the input should be in a bit reversal order to get the output in natural order. ठीक है? So ये very important part है. अगर आपका input bit reversal order में अगर नहीं देंगे आप, so you will get the wrong answer. Can you remember this step? Very important.
Yes, sir.
For
Yes.
DIT FFT algorithm, we are applying the input in bit reversal order. ठीक है? तो bit reversal कैसे याद रखना, ये याद रख सकते हैं आप? Can you remember this table?
हाँ, sir.
Yes, sir.
Okay. We just hope you have completed this diagram table. उसके बाद एक लाइन
Yes.
लिखो यहाँ पे. Just note here. तो पहला टेबल का पहला कॉलम टाइटल क्या लिखे? इनपुट सैंपल इंडेक्स यू राइट. इसका टाइटल जस्ट राइट इट एज इनपुट सैंपल इंडेक्स. इनपुट सैंपल इंडेक्स. बियर विथ माई हैंड राइटिंग. ऐसे भी हैंड राइटिंग खराब है और यहाँ पे तो पूरा खराब आ रहा है. राइट? इनपुट सैंपल इंडेक्स सेकेंड कॉलम का टाइटल क्या लिख रहे हैं? बाइनरी रिप्रेजेंटेशन. Write the title of second column as binary representation. In the title of third column you write bit reversed binary. Title of third column you write bit reversed binary. And fourth column title you write bit reversed sample index. Bit reversed sample index. Or
Yes, sir.
just add one line there. In DIT algorithm, DIT should be capital. DIT, decimation in time. In DIT algorithm, we can find that in DIT algorithm, we can find that in order for the output sequence, to be in natural order, in bracket you write x of k, that is capital X of k, where k is having the value k equals to like 0, 1 up to n minus 1. Capital X of k is equals to 0, 1 up to n minus 1. The input sequence had to be stored. The input sequence had to be stored in a shuffled order. Shuffled, SHUFFLED, has to be stored in shuffled order or bit reversal order. Shuffled order or bit reversal order. Full stop. For an 8-point DIT algorithm, the input sequence is what we will write? X of 0, X of 4, X of 0, X of 4, X of 2, X of 6. In between, you just write comma. X of 6, X of 1, X of 5, X of 3, and X of 7. X of 1, X of 5, X of 3, and X of 7. Full stop. We can see that when n is power of 2, the input sequence must be stored. In bit reversal order. For the output to be in natural order. Right? So this is how we are giving the input to the DIT FFT algorithm. So what are the main characteristics with DIT FFT? One is, what are the characteristics? You may expect this as a theory question again. First one, what we have seen? What is
Memory
the
requirement and in-place computation.
first characteristics is memory requirement and in-place computation, and second one is
Bit reversal order.
bit reversal order. Okay, very good. Hope you understood this. Any confusion here?
No, sir.
No, sir.
Now, let's take an example. We'll go for the example now. Just write example. Find the 8-point DFT of a sequence. Find the 8-point DFT of a sequence. X of n equals to, find the 8-point DFT of a sequence. X of n is equals to, X of n is equals to, we have it is 4 times 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, using DIT FFT radix 2 algorithm, using DIT FFT radix 2 algorithm. Okay. Now, just write solution. Solution. So here, as we want to calculate the DIT FFT of this particular question, X of n equals to, how many point it is?
8 point.
8
8
point.
point. तो अभी हमें यहाँ पे the important thing to be remembered is, so we must know the value of this omega 8 0, omega 8 1, क्योंकि ये मल्टीप्लायर्स है अपने, omega 8 2, omega 8 3, okay, which will be equals to, कोई बताएंगे अभी मुझे इसके वैल्यूज कुछ याद है आप लोगों को? We already calculated in the second chapter. So this value is how much?
1.
1. Next, what is the value of this? Omega 8 to the power 1. कुछ याद है?
One by root 2 minus j1 by root 2.
Very good. It is 1 by root 2 minus j 1 by root 2. Next, next value is
Minus j.
minus j. Okay, and this one is again
Minus 1 by root 2 and minus j1 by root 2.
it is minus 1 by root 2 and minus j 1 by root 2. अगर ये 4 वैल्यू पता है आपको तो फर्दर वैल्यूज यू कैन कैलकुलेट वेरी इजीली. कैसे कैलकुलेट करेंगे? ओमेगा 8 टू द पावर 4 will be equals to, what is the value?
Minus 1.
Is minus 1. Omega 8 to the power 5 will be equals to, what is the value?
Minus 1 by root 2 plus j1 by root 2.
Minus 1 by root 2 plus j 1 by root 2. Then omega 8 to the power 6 will be equals to
J.
j. Then omega 8 to the power 7 is equals to
1 by root 2 plus j1 by root 2.
1 by root 2 plus j 1 by root 2. Getting my point?
Yes, sir.
यहाँ पे I think something बराबर है क्या वैल्यू है? Whether you have checked the value? Anybody? बराबर है
Yes.
ना?
हाँ sir.
Okay. Now, so for all, each example, you should remember these values. At least 4 value अगर याद रखेंगे, तो further values we can write. Now, can I move further?
Yes sir.
So let me go further part. So how many stages we require here? अभी हमें 3 स्टेज चाहिए, right? So this is 1. Let me draw it like this. So 1. First line 1, 2, 3, 4, 5, 6, 7, and last one is 8. तो अपना ये डायग्राम हमें याद रखना है अभी, ठीक है? तो यहां पे सो व्हाट विल बी द इनपुट? इनपुट क्या होगा बताएंगे मुझे? तो फर्स्ट इज द इनपुट शुड बी इन बिट रिवर्सल ऑर्डर. तो यहां पे आपका रहेगा x of 0. Here we will write x of 4. This is x of 2. This is x of 6. This is x of 1. This is x of 5, x of 3, and x of 7. So this is our input in bit reversal order. ठीक है? Getting this?
Yes, sir.
Yes sir.
Now, so you just write down the values also such that you will not get a confusion here. X of 0 का वैल्यू क्या है यहाँ पे? 1. ठीक है? और x of 4 का वैल्यू क्या है?
0.
0. यहाँ पे 1, 0, 1, 0, 1 और 0. Understood this first step?
Yes, sir. Yes, sir.
ओके. नाउ यहाँ पे पहला स्टेज का डायग्राम क्या है आपका? सो व्हाट इज द फर्स्ट स्टेज डायग्राम? तो यहाँ पे लेट अस राइट द फर्स्ट स्टेज डायग्राम एज, तो ये पहला पार्ट है, राइट? सो दिस इज व्हाट द डायग्राम वी आर ड्राइंग हियर फर्स्ट. तो ऐसे कितने एक्सपेक्टेड है अपने? सो दिस इज अवर फर्स्ट डायग्राम. इट्स मल्टीप्लाइड बाय 1. और यहाँ पे W8 to the power 0. Understood?
Yes, sir.
Now you write separately. First, let us calculate x1 of 0. x1 of 0 is equals to, कोई बताएंगे मुझे आंसर? अभी मुझे यहाँ पे आउटपुट कैलकुलेट करना है. आई एम जस्ट कैलकुलेटिंग द आउटपुट एट दिस पॉइंट, राइट? So let me take here the output as a stage 1. x1 of 0 मुझे कैलकुलेट करना है, ठीक है? तो अभी यहाँ पे anyone tell me what is x1 of 0? कोई बताएंगे मुझे? What is the value of x1 of 0?
X of 0 plus
x of 0 plus
omega
W8,
8
हाँ, omega 8 to the power 0
into x of 4.
x of 4. Is everyone understood this?
Yes, sir.
समझ में आ रहा है? Any difficulty here?
No, sir.
No, sir.
Now what is value of x of 0? X of 0 value is
1.
1 plus omega 80 value is 1 into x of 4 value is how much? 0. So which
0.
will be equals to 1. तो इसका आंसर आया आपका 1. So this will be equals to 1 it is. Understood?
Yes, sir.
Hello? Hello?
Yes,
Yes,
sir.
sir.
Uh, sorry here like due to electricity problem कॉलेज में लाइट चला गया है उसके लिए सिस्टम बंद हुआ है अभी आई नीड टू स्टॉप द लेक्चर हियर ओके we will continue again further in the next class like
Okay,
almost
sir.
3 minutes we have left out here please mark your attendance so if anybody is having any questions you can ask me till that time किसी को कोई confusion for calculating the values can you calculate that stage 1 output if possible you try for that let's see otherwise tomorrow I'm going to explain it once again Nivedita is there? Nivedita Bhavan Bhaganagare.